So when I am working with quadratic regression and I am using Desmos, first off, I've built a table and I have entered in my regression model formula or quadratic regression, and it is y sub 1 tilde ax sub 1 squared plus bx sub 1 plus c. So notice that it's very, very close to our standard form of a quadratic. The only difference is that we have subscripts and the tilde instead of the equal sign. And the reason we have subscripts for x and y is because if you notice the table above it, when the table which we're going to be putting our data in, it has x sub 1 and y sub 1. So this regression model says that I'm going to be using the data from the table and entering it into my regression model. So I did have a question that we covered in class in regards to area of a rectangle in relationship to its width. And when I look at this, one of the first things I want to do is identify my independent and dependent variable. So my independent variable is width, and my area is y, or my dependent variable is y. And the reason I want to do that is so that I can make sure that I enter them correctly into the x and y table. But it will also help me later if I have to answer questions in regards to a specific width or a specific area. So I'm going to fill in my table. So 5, 7, 15, and 22. And have a y value of 40, 70, 270, and 550 here. So if I'm looking at Desmos right now, what I'm seeing is my red graph or my regression model. And what I'm going to do is I'm going to set my window of my graph here to reflect the x values and the y values so that I can see my data set in its full entirety without being squished or really tight. So I'm going to come right up here to the little wrench, and where my x-axis is, I'm going to change that from -10. And I'm going to start, since my table starts at 5, I'm going to start at 0, so just a little bit behind my table. And my table ends at 22, so I'm going to end my x values at, let's say, 25. And I'm going to do the same thing with my y. So my y starts at 40, so I'm going to start at 0 because that's not too far off. And my table ends at 550, so I'm going to set my window to 600. So just a little bit below the data set and a little bit above. And you can see now those green dots are my data sets, and the red function is my regression model. So if I look back at my regression model and I look at the residual value, r squared, r squared is 1, meaning that this model is a perfect fit for this data. And if you look just below that is something called the parameters. This is your a, b, and c value. So if I wanted to come up with a regression model, it would say 1x squared plus 3x plus, and now that particular decimal is extremely close to 0, so I can just put a 0 instead. Now from this regression model, you can do a lot of things. You can determine a specific value on your prediction model, so given the x or given the y. So for example, if I wanted to know what the area was if my width was, let's say, 60. Well, if I look back at my table, width is represented by the letter x, so I can put x is equal to, and let's say I wanted to know when my width was 60. So I'm going to zoom out here until I can see the intersection. So x is that black function there, and my regression model is in red, and I'm looking where they intersect. So if my x value was 60, then my y value, or my area, would be 3,780. So you can still use your regression model to help identify specific values outside of your data set. So for example, if I wanted to know this time, I didn't want to know width. I wanted to know if my area is a certain value, then how big is my width? So area here is represented by the letter Y. Let's say I want to know when my area is 1200. So you can see it did drop, and I'm going to change it from red to, let's say, green, just so that we have different colors here. My green is where my area is 1200. And remember, red is my prediction model. So I'm just looking at where they intersect. And so when my Y value is 1200, my X value is 33.17. So you can use it that way. Now, the most important thing about determining like a Y value given it a certain value for X is that you're looking for the intersection. So sometimes the intersection happens at 0, 0. Sometimes the intersection happens in an easier spot to see, but like some of those examples, we had to zoom in and zoom out. So when you're looking for specific values of X or specific values of Y, you first need to determine, what is your independent and what is your dependent variable based on your set of data.